This is going to be 34-5, so we'll get right into it. So we get number 1. Now remember, when we're graphing cosecant and secant, the reciprocals, we're pretending like it's either sine or cosine. So in this instance, I said we are going to pretend like it's sine, just for now, which means that there's a reflection over the x, my sine pattern, and there's going to be a horizontal shift that's going to be applied. So I take the x plus pi thirds. It's the messiest pi thirds known to man. So subtract pi thirds from everything. So I get negative pi thirds is less than or equal to x, which is less than or equal to. Now for this is going to give me 5 pi thirds. So once again, we create the box. Negative pi thirds, 5 pi thirds. So add these together, divide by 2, that gives me 4 pi thirds, divided by 2, that gives me 4 pi 6, or 2 pi thirds. And then for these, add these together and divide by 2, that gives me pi 6, and then add those together and divide by 2, that's 7 pi 6. Which makes this 10 pi 6, 10 pi over 6, and then this would be negative 2 pi over 6. So it looks like it's going up by 3 pi 6 every time. So now, drawing my graph, we have to scale everything. So it looks like we're scaling everything by pi 6. So my first at the center line is going to be at negative 2 pi 6. Say those are my y values. Then the next, so that's, I'll label it. So we have negative 2 pi 6, and then we have pi 6, and then we have 4 pi 6, 2, 3, 4, 7 pi 6, and then 10 pi 6. So there's my first one. Now because of the reflection, that means it's going to reflect, instead of going up, it's really going to go down. So the next one, it's going to go down, then it's going to cross, then it's going to go up, and then it's going to go crossing. Now because it's cosecant, I said that wherever it crosses the center line, you get asymptotes. And then at the peaks, you draw these parabolas. Now once again, this could be a trick question. If I asked you, what's the amplitude of a cosecant? The amplitude doesn't exist. Alright, let's look at another one. So we get number 2. So y equals secant of 3x minus 2 pi plus 4. So we're going to pretend like this is cosine. So then I put 3x minus 2 pi between 0 and 2 pi. So I'm going to add 2 pi to everything. Divide everything by 3. And so now I can create the value box. 2 pi thirds, 4 pi thirds. Add them together, divide by 2. That's going to give me 6 pi thirds divided by 2. So that's going to be 3 pi thirds. And then add these together and divide by 2. That's going to give me 5 pi 6. and then add 7 pi 6. So make everything into 6. So this is going to be 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, and 8 pi 6. So it looks like it's counting up by pi 6 every time. It makes it easier on us. There's no amplitude I have to worry about. I do have to worry about a vertical shift though. So in drawing this, because we scaled everything into 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6. So here is 4 pi over 6. I'll say this is 6 pi over 6 and then 8 pi over 6. Now the center line, it does shift up 4 spaces. 1, 2, 3, 4. So then I do the cosine pattern from that center line. So amplitude, cross, amplitude, cross, amplitude. Now because it's secant, that means that where it crosses the center line, you draw asymptotes. And then at the peaks, you draw those parabola looking things. Now number 3 and number 4 going to be very, very similar to what we just did here. For number 5, look at a previous DI for tangent. Every single previous DI has had a tangent mixed in there. Alright, let's move on to number 6. So number 6, it says use the graph of y equals f of x below to answer the question. So remember, these are all the different ways that we can describe a graph. So for example, the domain. Well, looking at that, it looks like it starts here at -5, and there's a graph everywhere all the way to 3. So I can say that like the domain is going to be from -5 all the way to +3. It says determine f of -2. Well, my x value is -2. What is my y value? So at -2, it's going to be +2. It says list the x-intercepts where it crosses the x-axis. It crosses here, here, and here. The zeros of f are the same as x-intercepts. For my class, we said that for x-intercepts, we're going to list the coordinates. So I'd list it as -4, 0, -1, 0, +1, 0. The zeros, I would just say -4, -1, and +1. So find the number of solutions for f of x equals 1. So when your function is 1, how many x values are there? Well, there's 1, 2, 3, 4. So there's 4 solutions. The intervals where your function's increasing. So that means that as you move from left to right, is my graph moving up or down? So starting at -5, as I move this way, my graph is moving up. So for increasing, so far I have -5 to -3. And then if you keep going, you keep going, you keep going, right when we get to -1, as it moves over, it's also moving up again. So union, -1 to +2. -1 to +2. Now, intervals that are decreasing would be from -3 to 0 because it's going down, and then right here it's also going down. Local maximums mean any single time that you have basically like a peak on your graph, to where on the left side and the right side you can definitively say on an interval that this is the highest value. So definitively, this is the highest value because I can keep going up and up and up and up, and then I can't go up anymore on both sides. Now this right here, so my local maximums would be 4 and 2. Now my local minimum, I only have this one right here, which is -1. This is not a minimum, a local minimum, and this is not a local minimum. And the reason is because the definition for us to say a local max or min, there has to be an interval where on both sides I can definitively say either this value for y is highest or this value for y is lowest. Well, for this value here, there's no both sides. There's only one side. So that definition doesn't then apply, so therefore I can't say it's a local max or min. Now this concept's important when you move on to calculus. We really have to be able to distinguish the difference between local max and mins and absolute max and mins. Now the absolute max and min is just what is the highest value. The absolute minimum is what is the lowest value. So the maximum, the highest value, is going to be 4. The minimum, the absolute lowest value, is going to be -5. The last little thing is, remember, an inequality. It's asking where your graph, so your y values, are they either above or below 0. So this says my y values being greater than or equal to 0. So where is it positive? So it's going to be positive between -4 and 1, right, because it's above 0, and it's going to be positive from -1 to 3 because it's going to be above 0.